And let's do a little chain rule notes.
All right.
So this is my, oh, what are we doing there? Hold on. We are in business now. This, the chain rule, is my good friend's number 3. I do have lots of good friends. What can I say? I'm going to expand this. So this would give me x squared plus 8x plus 16. And if I were to take the derivative of this function, derivative of x squared is 2x, derivative of 8x is just 8. And these two things are equivalent, right? I could factor out a 2. So let me show you the chain rule, okay? Because if I just have a square there, that's fairly easy to solve. But if it's something like x plus 4 raised to the 20th power, that's more complicated. So we got to use the chain rule. All right, so the chain rule would be this. I have y prime is equal to 20 x plus 4 raised to the 19th power, and then times 1. So where does the 20 come from? Exponent is moved out front there. The x plus 4 comes down. Where does the 19 come from? I'm going to subtract 1 from the exponent, and now where does the 1 come from? Let me do another one, and it's probably a little more clear. Here, let's see, 20 comes up front. The 2x to the third plus 4x comes down. I'm going to subtract 1 from my exponent, which would give me 19. And then I'm going to multiply by the derivative of what's inside there, which is 6x squared plus 4. So the 1 here, it comes from the derivative of x plus 4. And this is why I give you M&Ms, because the chain rule is like an M&M. This right here is the shell. This right here is the derivative of the chocolate. Look at that. Hold up. So let me just get on my little calculus soapbox here for a second. Because this is going to happen. I know it is going to happen. I do not want it to happen, but there is nothing that I can do. One of you little darlings is going to forget to take the derivative of the chocolate. I know it. I would bet my house on it. In fact, I have. And I haven't moved recently. I'm still there. But you may be sitting there thinking, no, coach, not me. I would never forget to take the derivative of the chocolate, but I say to you that I'm going to be grading your little chain rule quizzes or assessments, and I'm going to say -1/2 or just mark it all wrong and write a little note up there that says chocolate, and you're going to be like, oh, as you hear the rooster crow faintly 3 times in the background, as you swore that you would never do this, but yet you did. Don't forget to take the derivative of the chocolate. Here's what the chain rule says. Y is equal to f of x raised to some power. So the notation, I want y prime. The n comes out front. The f of x comes down. I subtract 1 from the exponent. And then I multiply by the derivative of the chocolate, which in this case would just be f prime of x. So let's look at this example. If y is equal to 3x plus 4 raised to the 7th power, find y prime. So the 7 comes out front. I bring down the 3x plus 4. Don't forget to subtract 1 from the exponent, so that would give me 6. And then I multiply by the derivative of 3x plus 4, which in this case is 3. And you might see that I can simplify this a little bit. The 3 I can multiply by the 7 out front, and that is going to give me 21, 3x plus 4 raised to the 6th power. Okay, questions on that? How about we take a little M&M break, right? If you haven't already disposed of them. Yes.
Would we have to simplify the?
Not necessarily, but if it's a multiple choice question, you might see it like that, okay? But unless I tell you to, I may tell you just leave it, okay? All right, here we go. Let's look at another example. We have y is equal to 3 plus the square root of x, and all of that is raised to the 4th power. So I'm going to rewrite this. 3 plus x to the 1/2 raised to the 4th power. So now I'm going to use my good friend number 3, the chain rule. The 4 comes out front. The 3 plus x to the 1/2 comes down. I subtract 1 from the exponent, which gives me 3. And then I multiply by the derivative of what's inside there. Derivative of 3 is
0.
And the derivative of x to the 1/2 is
1/2
x to the negative 1/2. My little power rule there. Okay. Any questions on that one? Well, the next one I like because my two good friends are getting together and socializing. We have g of x is equal to x cubed times 2x minus 5 raised to the 4th power. They're multiplied together. So to take the derivative, I got to use my good friend number 1, the product rule. And I'm a little slow today, as usual. What's the product rule? I always forget. It's the, hold on, let's work it out. So it's the first term, which in this case would be x cubed, times the derivative of the second. And the derivative of the second, I'm going to have to use my good friend number 3, the chain rule. So the 4 comes out front. The 2x minus 5 comes down. I subtract 1. And then I multiply by the derivative of the choco latte there, which would be 2. So that is the first part of the product rule. And now I got to do the second part, which says the second term, 2x minus 5 raised to the 4th power, times the derivative of the first, and derivative of x cubed is 3x squared.
Is that it?
That's it.
So did you only do the product rule on
I
that?
just did the product rule. I didn't simplify. Most of the time, I'm just going to ask you to leave it without simplifying.
Where'd you get the 4? Is that the
It's the
exponent?
derivative of this, so the 4 comes out front. Got it?
Yeah.
All right, well, let's add a little trig, shall we? Indeed we shall. Here we go. So I'm going to rewrite this as it helps me to think of it if I write it like this. Sine of x raised to the 3rd power plus cosine of x raised to the -5th power. And I do that so that I can do the chain rule here. So the derivative of y prime, the 3 comes out front. The sine of x comes down. I decrease my exponent by 1, which would give me 2. And then I'm going to multiply by the derivative of the chocolate there. And derivative of sine of x is what? Is cosine of x. And then plus, but it's not going to be a plus. Why? Because I want to do the chain rule again, and this -5 is going to come out front. So it's going to give me -5. Bring down the cosine of x, and then I'm going to subtract 1. Just be careful there. -5 minus 1 is -6. And then I finally got to multiply by the derivative of cosine of x, which is negative sine of x. All right, how about we take a little M&M break? Have another M&M if you haven't already eaten all of them. Especially if you have a peanut one, because we're about to do one that's a peanut type. I'm going to write this as sine of 7x raised to the 3rd power. And I'm going to do the chain rule. So the 3, excuse me, the 3 comes out front. The sine of 7x comes down. And then I'm going to square it, subtracting 1. And then I'm going to multiply by the derivative of what's inside. And so the derivative of sine of 7x is going to be cosine of 7x times 7. So look, I got shell, I've got chocolate, I've got peanut. Let me go through it again.
Why did you multiply by 7 again?
Oh, we'll explain. Let me go through it. Okay. So 3 comes out front, sine of 7x comes down, subtract 1 for the exponent to get 2. Then I'm multiplying by the derivative of sine of 7x. And so the derivative of sine of 7x is cosine of 7x. So the 7x that's inside the parentheses comes down. And then I got to take the derivative of the 7x there, which is 7. Okay? So derivative of sine of x is cosine. The 7x comes down. And then I take the derivative of the 7x, which is 7. Yes? Let me do another example. I have the square root of x sine of 2x. So I'm going to write this as x sine of 2x raised to the 1/2. So I'm going to take the derivative, y prime. The 1/2 comes out front. The x sine of 2x comes down. I subtract 1 from my exponent. 1/2 minus 1 is negative 1/2. And then I'm going to multiply by the derivative of what's inside here. And when I do that, look, I have x times sine of 2x. So I've got to do the product rule, my good friend. Okay, let me label them. Okay. U, B. So I've got my first term, which is x, times the derivative of sine of 2x. And what's the derivative of sine of 2x? It's going to be cosine of 2x times 2 plus second half of the product rule. Well, no, it's sine of 2x times the derivative of the first term, which is just 1, and close it with brackets.
Why do you multiply cosine 2x by 2?
Okay, so let me go through it again, and let me label these, and I think that you'll get it.
What's the answer though?
It's all of this.
Oh my goodness.
Okay, so I've got 1/2 out front, that comes down, subtract 1, then I take the derivative of this, and when I do the derivative of this, I've got to do the product rule because I have 2 terms. My first term is u, my second term, v here, is sine of 2x. So when I do the product rule, I've got u times v prime. So I've got x times the derivative of sine of 2x, and the derivative of sine of 2x is the cosine of 2x. 2x comes down. Then I multiply by the derivative of the 2x, which is 2, plus second half of the product rule. I've got v and then u prime. So I've got the sine of 2x times the derivative of x, which is 1. And then if I do not put this in brackets, it is wrong. Why is it wrong? I didn't put brackets over here. Well, these are all multiplied together, but if I leave off the brackets, then I'm just multiplying this by the first part of the product rule, not the entire derivative.
Can I put parentheses?
Sure. Okay, but it must be enclosed then. Otherwise, it's not correct. How about I give one to you to
No.
try? Bring it on, coach.
I do it.
All right, well, how about this one? How about we do, let's see, y equals, let's say 3x cosine of 4x squared raised to the 10th power. Are we whining again? I believe that you have reached your wine limit for the day.
Oh my goodness, I want to do it.
Wait, so squared, is that applying to the cosine or the term 4x?
It's just the x term. It's 4x squared.
Okay.
So it's cosine, parentheses, 4x squared. How about you collaborate with your friendly calculus neighbor there? Socially distancing, of course. See how he or she is doing. Conference.
I mean, I can take another evidence.
No,
Why not?
no, it's only for special students.
Ooh. You know, just Give me one too, Rachel.
You've already had two.
It's a fair point. Are we done with our math?
Yes.
Check it, see if it's right.
I'm on the second part.
I was like, yeah, where did you?
I was like, I don't know where I got it.
Wait, you think that was 16 digits?
Yeah, that's what I did.
I just heard him say 10 so.
All right, here we go. Someone help me out here.
I got 30x cosine 4x squared.
My chain rule skills are a little rusty. All right, here we go. Come back together here for a second. I have the 10 comes up front. I bring down the 3x cosine of 4x squared. Subtract 1 from the exponent, which gives me 9. Now I'm going to multiply by the derivative of what's inside here. There are two terms. First term is 3x. The second term is cosine of 4x squared. They're multiplied together, so I got to use the product rule. Let me put my little brackets here. So I've got 3x, first term, times the derivative of cosine of 4x squared, which is, it's going to be negative sine of 4x squared times 8x, derivative of the 4x squared, plus the second term, cosine 4x squared times the derivative of the first term, which is 3, and close the brackets. And I'm going to leave it like that.
Ish. Oh, I didn't. Never mind.
All right. We're going to break on through to the other side. Here we go.
It's just a big mess.
Well, here it says find dr d theta if r is equal to secant of 2 theta tangent of 5 theta. So I have two terms. Again, they are multiplied together. I'm going to use my good friend the product rule to find dr d theta. So I have the first term, secant of 2 theta, times the derivative of tangent of 5 theta. And what is the derivative of the tangent of 5 theta?
It's secant squared. 5 theta. I know that's right.
I am pretty sure that my house is yet again safe.
0.
Hadn't heard it, the correct
Theta times theta.
derivative of tangent of 5 theta is going to be
Yeah.
secant squared of 5 theta times the derivative of 5 theta, which is 5. Chocolate, derivative of the chocolate. I told you like 10 minutes ago, you're going to forget. You proved me right. Plus, that's only the first part of the product rule. So I got the second term, tangent of 5 theta. Okay, we'll see what you got. What's the derivative of the secant of 2 theta?
I don't know what that is.
Secant term.
Hold on, wait. Let me just
It's secant.
let me make an observation first before you answer. I think Newhouse told you that you should probably learn your trig derivatives, like especially before the test that we had yesterday.
Well, I
This
knew-
is still true going forward. You need to know your trig derivatives. I'm sorry, Joe, you were about to elaborate. The derivative of the secant of 2 theta, and I interrupted. What do you got?
I think it's secant tan 2 theta times.
Joe. He's right.
Is it?
He is close, but he is not quite right. Because what's the derivative of the secant of x?
Secant.
Secant x tangent x. So derivative of secant of 2 theta is going to be secant 2 theta tangent 2 theta times 2. Why is it times 2 and not 4?
Chocolate.
Well, it is the chocolate, but I'm taking the derivative of 2 theta here, which is just 2. Okay, so let's not make that mistake and write it as secant tangent 2 theta. That is incorrect. It's secant 2 theta, tangent of 2 theta. Okay. Whew. Well, that's enough of that for the day. Let's do something related, but a little bit different. We're going to do composite functions and function notation. So both of these will give you the same answer. There's just a little bit different process of getting there. So let's do composition first. Okay, and by composition, I mean I'm taking this function and substituting it in for the variables in the first function here. So I'm going to take cosine, and then instead of writing x, I'm going to substitute in g of x, which is 4x plus 10. And so now I'm going to take the derivative. What's the derivative of cosine of 4x plus 10? It's going to be derivative of cosine is negative sine, so negative sine. Bring down the 4x plus 10 times the derivative of the chocolate there. Derivative of 4x plus 10 is 4. So most likely you would see it like that. That 4 would come up front with the negative 1 there. So negative 4 sine of 4x plus 10. So that was the composition way. This is the function notation way. So function notation, we have f of g of x, and to take the derivative, we always do this. F prime, the g of x comes down, and then we multiply by the derivative of g prime of x.
Holy crap.
So, for example, let's find f prime. F of x is equal to cosine of x, and so the derivative of cosine of x would be negative sine, but instead of putting x, I'm going to substitute in g of x, and then multiply by g prime of x, just following this notation here. Okay, so what is g of x? It is 4x plus 10. And the derivative of g of x, g prime of x, derivative of 4x plus 10 is just 4. And I end up with the same thing that I got with the composition one.
Wait, so why are we doing the chocolate part on this question?
Say that again?
Like, why are we doing the chocolate part? Like, adding the.
Because it's a trig function. So that's why, like right here, you're talking about this.
Yeah, I'm saying, why do we have to find that for? Yeah.
Because whenever you're doing the derivative of a trig function there, it's the derivative of the trig, and then what's in parentheses comes down, and then you multiply it by the derivative of what's ever inside the parentheses
Okay.
there, which in this case was 4.
So before we didn't have anything in the parentheses?
Correct. Exactly. Technically, there was a 1 there
Okay.
because the derivative of x, right? Does that make sense?
Yeah.
Okay, so again, let's do it 2 ways. Let's go composition, which means I'm going to take the 7x and substitute it in for the variable. So 7x squared plus 4 times 7x. And now I'm going to expand that a little bit. So that's going to give me 49x squared plus 28x. And I still haven't taken the derivative. I'm gonna do that now. So derivative of 49x squared, 2 times 49 is 98x. And then I got a plus 28. So same thing over here, function notation, f of g of x, f prime, bring down the g of x, times g prime of x.
How do you get 49x squared?
I have 7x squared.
I was thinking we multiplied.
Okay. So here, first step is to find f prime. So I'm going to take the derivative of f of x. F prime would be 2x plus 4. So I've got 2, and then instead of x, I'm going to substitute g of x. So I've got a g of x in there, plus 4, and then I've got g prime of x. So all I did, I took the derivative of f, that gave me f prime, which was 2x plus 4. And then I substituted in g of x for the variable, and following this notation, I multiplied it by g prime of x. What is g of x? In this case, it's 7x plus 4. And g prime of x would be, therefore, the derivative of 7x, which is 7. So that's going to give me 14x plus 4 times 7, which is 98x plus 28. Whew. Probably another time for an M&M. We got one more. It says find the value of fog prime at x is equal to 1. What does that mean?
F and
It's not fog, it is,
F of G.
it's the composition. So I want the derivative of f of g of x. Same thing that we just did on the last two examples, but at this time they want me to evaluate it at a point
Oh,
at x is equal to 1. All right, so let's do a little composition. I'm going to take the square root of x and plug it in for the variable. So that's going to give me 2. And then I'm going to write this as an exponent, x to the 1/2 raised to the 3rd power plus 5. Oh no, exponents and fractions. Come on, Algebra 1 students. What do you do when you raise a power to a power? You multiply. So this is going to give me 2x to the 1/2 times 3 is 3/2 plus 5. So up until now, I've just simplified the composition. Now I need to take the derivative. Ooh, I'm in issues writing derivative there. Try that again. So derivative of 2x to the 3/2. 3/2 times 2 gives me 3. And then I subtract 1. 3/2 minus 1/2 is 1/2. And derivative of 5 is 0. And they want me to evaluate it at x is equal to 1. So I've got 3 times 1 raised to the 1/2, which is 3. Or I could do it this way. I got the function notation, f prime, g of x, g prime of x. So I need to find f prime. F prime is going to be the derivative of 2x to the third plus 5, which is 6x squared. So let's see, I've got 6, and then I'm going to substitute in g of x for my variable, and that's squared. And then I multiply times g prime of x. And so now what is g of x? It is the square root of x. So I'm going to substitute that in here. So I've got 6 square root of x squared times the derivative of g of x. What's the derivative of x to the 1/2?
Half x
You
negative.
follow me? Okay. Let me help you then. I have f prime is 6x squared. You with me? Okay. So instead of writing 6x squared, I wrote it as 6, and then I substituted in g of x for x, and then it's squared. And then following this notation, I'm multiplying it by g prime of x. Got it? Okay, so now what is g of x? G of x is square root of x. So I substituted that in there. And now I've got to multiply by g prime of x. So I need the derivative of the square root of x. So the derivative of x to the 1/2 would be 1/2 x to the negative 1/2. And let me clean this up. Square root of x squared is just 6x times 1/2 x to the negative 1/2. I'm evaluating it at x is equal to 1. So that's going to give me 6 times 1 times 1/2 times 1 raised to the negative 1/2, which is 6 times 1/2, which is just 3. My work here is done.
Yes.